Hi, in this video, we'll be covering about lines and planes in three-dimensional spaces. And so, what is a line in 3D space? It is actually determined by a point and a vector parallel to the line. And so you can think of the line as an object in 3D space. So it goes here. And if you have a point and you know how to travel along the line, which is what it means to have a direction, a vector parallel to the line, then you can find every point in this line, and then and so you can represent the entire line. And so the vector equation is just given by a position vector, which is the point, and then a vector parallel to the line multiplied by a scalar, and the scalar can take all real numbers. And if you were to expand our component wise, then you recognize that x can equals to x0 plus tv1, and similarly for y and z. And this is known as the parametrization of the line. So you just need a parametrization is giving if the parameter is now t, and so a parametrization is having these three conditions on your set. And what we like to note is that the parametrization is not unique, and you can have different parametrization for the line. But this parametrization just represent in physically space in physical space the direction and speed that you are traveling with. So what we want to do is now we have points and we have lines, and we want to find the interaction between them. And so we can find the distance between a point and a line using this formula, and you can really verify it easily, because if you want to find a distance from the point to the line, you just need the perpendicular distance, which is this vector times sine theta. And what is PS? PS is just the vector from a point on the line to the point that you want, and then you cross it with V, and so you're done. And so we can take a look at this example. So we know a known point is 130, and so PS is just 115 minus 130, which is 0 minus 2, 5. And then we just cross it with V to get 152, and then we just find this length divided by the length of V, which is square root 5. Another form of interaction is when you have two lines, and whether they are, so in 3D space, two lines can be either parallel or non-parallel, either intersecting or non-intersecting. But in 2D space, if you have two lines, they are either parallel and intersecting or not intersecting. So parallel and intersecting means the lines are just equal, or else if they are parallel, then they won't intersect. But if they are not parallel, then they definitely intersect. But in 3D space, because you add a third dimension to this line, these lines can lie on parallel planes and not be parallel to one another. Yet, so from the top view, you see them crossing, but they are not actually intersecting, but they are not parallel. And these are known as skewed lines. And so, generalizing from lines, we have this thing known as planes. Planes are basically a space spanned by two vectors now. And so there's two parameters. You can either go in this direction or both, in a mixture of both. And so really the vector, a position vector on this plane can be represented in what is known as a parameter form, is when you R equals to R0 plus S V0 plus TV1, where V1 and V0 span the plane. And really, if you want to make it easier, you can take v0 and v1 and you cross product it to get a vector perpendicular to the plane, and that really gives you a one vector that orientates the plane. Because if you know what's perpendicular plane, then you know every vector in this plane is perpendicular to this n, and this n is just called the normal vector. And so now you can represent with a point and a vector, because if you have a point, another point, a known point, and a point you want on the plane, then you just need to find the vector in between them, which is r minus r naught, and this n is perpendicular r minus r naught, and so the dot will equal to 0. So n dot r equals to n dot r naught, and that's why, because r is a point on the plane and r naught is a known point on the plane, they are equal. So really it just be n dot r equals to some constant. And if you write out Cartesian form, then this is what you get. So it's some form ax plus by plus cz plus d. And really the parametric form is in two parameters now, s and t, of v0 and v1. So x equals to x0 plus s v0 plus t v0, and then y equals to y0 plus s vy0 plus t vt y1, something like that. So now you can find the equation of a plane, and you really just need to find the normal vector, and then using this formula you can just plug it in, or if you understand this, you just use that. They're all equivalent formula to represent the plane. And like objects interacting, we can find how objects interact in between planes, and between two planes they are parallel if their normals are parallel, and if they are not parallel, then in this case now they will be intersecting, because it's 3D space. Of course, if it's in 4D space, then you can have non-parallel planes that are not intersecting, similar like how you generalize from 2D to 3D. And so now you can really see, once you understand how to generalize from 2D to 3D, you can really generalize it further to Rn. And when two planes intersect, you can think of the intersection as a line. And so what this line, how do you find? Is just taking the direction. It must be perpendicular to n1 and perpendicular to n2. So you just need to take the cross product of n1 and n2 to find the direction vector of the line. And then find a common point between P1 and P2, and then you can represent your line already. And we also said that the angle between two planes can be represented by taking the modulus of the absolute value of the dot product of n1 dot n2 over the length of n1 times n2. And the reason for that is the angle between the normals, you can show geometrically it's equal to the angle between the planes. Lastly, we will just look at the distance between a point and to the plane. And really it's because you want to find the perpendicular distance here. And so you just need to take PS dot with this n, because you want to project it and find the scalar component. And hence the distance formula is just PS dot n over the length of n. And if you expand on this formula, you actually get this, which you can read along here. And so we'll practice an example to really understand it. So you want to find the distance between two parallel planes. And they're parallel because their normals are parallel. And so you pick any point on this plane and any point on this plane. And then you just need to find the distance. You just need to take the vector from this point to the other point. So there's two planes here. And then you just dot it with the normal vector. And really, Once you do that, you actually get this result, and you simplify it, you get square root 3 over 6. So that's all for this video. I hope you have enjoyed this video. Please feel free to like, share, and subscribe. And I'll catch you in my next video. Bye!